Hello students, welcome back again to another video from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be following up on our previous video that we had done on transposition. Of course, this is in fact part 3 of this topic. In part 1 we had discussed the very basic concepts involving balancing the equation on both sides, splitting the product, and creating a new subject. In part 2, which was posted a few days ago, you would have seen where we spoke about transposition involving factorization. So it is highly recommended that you do check out those 2 previous tutorials before continuing with this one. However, if it is that you have already have good foundation in those 2 areas, then we can proceed into this video. Of course, primarily my channel focuses on helping Caribbean students in preparation for exams on a yearly basis, but of course my lessons here spread wide and far, both for college students and college and secondary education students. So primarily my focus is on the Csec, SCA, CCSLC, EDXL and IGCSE exams paper. Alright, so I do a wide variety of content here on the channel, and of course I particularly target the areas that I find are a challenge for students and that are most important to becoming a strong math student. So of course, if this is the first time here on the channel, do consider subscribing to the channel, leaving some positive questions and comments down below into the comment section. Do not forget to share this out to your math communities, friends, colleagues, students who are currently struggling or need a bit of reassurance when it comes to math concepts. And of course, do not forget to hit the like button. It really does help the channel to grow. So let's dive right on in and see what this topic is all about. Here we go. By the title, you're seeing that transposition involving roots and powers, and I have some information here for you that we have presented on screen, and I have a bunch of examples to which I'm going to be walking you through so we can apply these roots here. So the very first thing is understanding what is a root. What is the root of a quantity? So it says here, by my definition, that the root of a quantity, or it doesn't have to be a quantity, can be a variable, basically describes the fact that there is a factor of that term, or there's a factor of that number, that which when multiplied by itself a certain amount of times will produce the same number that you're trying to find the root of. So just to give you a bit of understanding of what I mean then, is that if you were asked to say here, find the square root of say 4, then this would mean that there is a factor of 4 that which when multiplied by itself will produce the result 4, and therefore then we looked at the fact that 2 multiplied by 2 is equal to say here 4. All right, or it could be, say for example, the square root of say 36, and so therefore there is a factor of 36 that which when multiplied by itself will give you 36, and that is in fact 6, because 6 times 6 is, say here, 36. Now if you're an intermediate student, most of these numbers are going to look a little familiar to you, but let's just say that you happen to be watching my video and you are not really very good at finding the square root of certain numbers, then there's actually a nice little way that you can actually do it. So here, say for example, I wanted to find the square root of say here 9. okay, and I really don't know what the square root of 9 is, then what we can do is that we can drop a little small table of values here. Okay, so I can just create like a little column here, okay, and I can put 9 here, and then I will choose the lowest prime factor that can go into, or the lowest number that can go into 9 here. So I will say here, let us try 3, and so 3 into 3 goes 3 times. Then I will use another prime number here, that's 3 into 3 goes 1 time. Now if I happen to get a 1 at the bottom here, then it means that the number that I've chosen, depending on how many times it repeats itself, that will therefore tell me the square root. So therefore, because there is 2 3's, it means that 3 times 3 is equal to 9. So that is the square root of 9. Now, I find it quite easier if it is that you just get familiar with the square root of certain numbers. When I was practicing math in my earlier days, I was forced to actually study the square table up to 30. So over the years, you know, I've gotten accustomed to the numbers, and so what I do recommend for you here is just to write down your square numbers from 1 to 25. That is, say 1 times 1 times 1, pardon me, 1 times 1, 2 times 2, 3 times 3, 4 times 4, and you can do this all the way up to 30. If you choose to go beyond 30, that's really up to you, right? But for the most part, I think that knowing the first 30 or being familiar with the first 30 square numbers and the first 15 cube numbers will stand to benefit you in the long run. All right, now what if it's not a case where it's a quantity? Let's say that we wanted to find the square root of, say here, x. That's going to be a little bit challenging because we don't know what x is. So then therefore the only thing that we can do here is learn how to isolate, say here, the x, or it doesn't have to be, say here, the square root of x. It could be the square root of a fractional quantity. So it could be the square root of, say, x over y. All right, or funny enough, it could be actually the square root of x divided by y, or it could actually be, say here, the x divided by the square root of, say here, y. So here we have just the square root of a single quantity. Here we have the square root of an entire fraction. Here we have the square root of the denominator, the square root of the numerator divided by the denominator, and this is the numerator divided by the square root of the denominator. So you can have any one of these combinations here, and that's what we really mean by the root of a quantity or the root of a, say here, expression or variable. Now as we move on here down to the fact that a root is basically the fractional power to which the quantity or the subject is raised. Hence we're going to need to know how to isolate the subject whenever it's covered by a square root or whenever it's attached to a square root. So it says here that to isolate the root from the subject, we have two ways we can do this, right? And different instructors at different level of math will teach you a different way. So I'm here to show you both ways here. Now, one is that you can either raise it to the corresponding power, or you can re-express it as a fraction and raise it to its reciprocal power. Let us explain that there. So let's say then that you happen to be rearranging an equation, and in the latter part of it here you end up with something like the square root of, say here, a. All right, now method one, for us to isolate the a, for us to get that a to be by itself, we can therefore go ahead then and say here, find the square root. So say to find the square root of a, we're going to raise it to its corresponding power. So therefore, what corresponds, the power that corresponds with the square root is in fact the power of, say here, 2. Okay, so we can therefore go ahead then and say square this. And so what that allows for me to do here is that it allows me to cancel, say here, the square root with the square. Now, I've had students that literally ask me, how does the square cancel the square root? Well, in reality, what is really happening is that the square root of, say, a quantity, let's just do, say here, the square root of b. What this means, what the square root means, and this is coming from one of the laws of indices that says a raised to the power of 1 over n is equal to the nth root of a to the 1. And so we are able to therefore convert a root of a quantity to a fraction, and then we can actually go ahead and convert a fraction back to a root. So let's say here then, if you ask, how does the square cancel the square root? As opposed to just accepting it for whatever the teacher says, you can therefore have a deeper understanding of how it is that the square cancels the square root. Because what this means then is that the square root of b is actually b raised to the power of a half. So you might ask then, sir, what if it is that it's not, say here, the square root? What if it's the cube root? Then, of course, it would then be the quantity raised to the power of, say here, 1/3. All right? So it would be the quantity raised to the power of 1/3. So then, what if I had, say, something like the 4th root? Let's say we had the 4th root of, say here, t. Then this would mean that this is t raised to the power of 1 over 4. All right, I'll be keeping it simple for now, right? We're not going beyond a half, a third, a quarter, 1/5. We're just keeping it like that. Okay, I will have a video coming out on indices that talks about how to convert from fractional powers to root powers. So we're going to look at that. So what this means then is that I need to isolate, say here, the fractional power away from the b. So what that means for me then is that I'm going to go ahead and I'm going to then raise it to the reciprocal power. Okay, so that's what we're saying here, is that we can re-express the quantity to its fractional form and then raise it to the reciprocal power. So what's the reciprocal of a half? That's going to be, say here, let's just put it here. It's going to be the reciprocal of a half here is, say, 2. And so that's what we mean by we're squaring both sides. So a half multiplied by 2 basically then cancels the 2 here and the 2 here. So that's why we end up with a final result here of, say here, b. So this is kind of like the reason why we see the square cancels the square root, because in reality the square root of a quantity is actually the quantity raised to a fraction, and then by multiplying the fraction by its reciprocal we cancel, leaving a numerator here of 1. All right, and then similarly, if we had the 4th root, which we most likely won't have, you're probably going to see stuff like this at a higher level in math. But in the event that you do see a question with a 4th root, then the 4th root of t is really t raised to the 1 over 4. It's always 1 over the root value here, so it's 1 over 4. And so basically then all I have to do then is to raise this to the reciprocal of a quarter. So the reciprocal of a quarter is 4. And so basically then by cancelling, say here, the 4 here, so if we raise it to the 4 here, we can cancel, say here, the 4 here and here, and then we end up easily here with t. All right, so hopefully that made a lot of sense to you as to why does the square cancel the square root, the cube cancel the cube root, the 4th power cancel the 4th root, and it basically follows that exact pattern. All right, so whatever the root symbol is, you can either raise it to the corresponding power, or you can reconvert it to a fractional form and of course raise it to its reciprocal power. All right, now we need to go back to this section up here. All right, and so what we're going to be looking at then is dealing with these types of situations that you're going to end up with later on. So for the first one here, it's pretty easy then. If I wanted to say here, get rid of the square root from the x, then I would obviously raise this to the power of 2. And so what that means for me then is that I'm going to, pardon me here guys, oops, pardon me. All right, so what this means for me then is that I'm going to just raise this to the power of 2, and so what that means then is that the square root will be cancelled by the power, so therefore we end up with, say here, x. All right, and then how do we deal with this situation then? Bear in mind that the square root basically covers, say here, both numerator and denominator. So once again we would proceed by squaring the whole entire fraction, and so basically then what happens then is that the square root will be cancelled then by the square, and so we end up then easily with access to the fraction, which is then x over y. Right, so once that is out of the way, then let's look at how to deal with the situation where maybe one part of the fraction is covered by the square root. So once again we have a choice. We could isolate the y, we could remove the y first, but if you want to just get the job done in one attempt, we can go ahead and square the whole fraction. So here's the challenge with this then. Once I square the fraction, right, just to get rid of this root sign here, what happens now is that this power here will cancel this root sign here. So basically we are just left with x. But remember that according to the laws of indices, power to power rule is that once you square a fraction, you have to square both the numerator and the denominator. So therefore then we're going to end up then with, say here, the square cancels the square root at the top, so you're just left with, say here, x, and then of course the square will also square the y. Remember, the square root is not connected to the y, so the y will be affected by the square. Okay, so we have x over y squared, and similarly then if we go ahead and say square this term here, all right, then what is going to happen then is that the x will be affected by the square, so we end up with x squared, and then of course the square will cancel, say here, the square root down here, and we ended up with here, say, y. So these are some little tips and tricks that you can use whenever you're dealing with square roots involving, say, transposition. All right, and there's many ways to go around it, but you can choose what you prefer. There's a lot of things going on here. There's a lot of prerequisite skills that you would need to really to be effective when it comes to transposition involving roots and powers. So you definitely need to make certain that you understand this before moving further into math. All right, and then even though my examples that I'm seeing here on screen are all square roots, square roots, square roots, square roots, if it was a cube root, it would be the same thing. If it was the fourth root, you'd apply the same, say here, principle. All right, and so we have a little bit of information down here that says that a root and a power are, as I said, one in the same, right? A root is just basically the quantity raised to a fraction written in a different form. All right, and so the basic rule then that we're going to be leaving, apart from all the different techniques that I've showed you so far, then the basic rule is that if a power is connected, whatever the power, might it be a square, a cube, a fourth power, a fifth power, then basically to isolate the power away from the variable or the required subject, then we're going to be using the corresponding root, and vice versa. If the required subject or variable is covered by a root symbol, then we use the corresponding power. So just to wrap this section or this segment of the video, then what we are saying then is that if we have a quantity then that, say here, is attached to that square here, and we need to isolate the x, then to remove the power we are going to use the corresponding root, so that the root will cancel the power, so we're then left with, say here, x. Or it could be a case where we have the square root of, say here, let's do cube root of y. Okay, and so to basically cancel that cube root, we're going to raise this to the power of, say here, 3, so that basically then the cube root will be cancelled by the power of 3, and therefore then we get access to whatever is on the root, which in this case here is y. All right, so that was a lot of information there then, why you may find yourself having a challenge when it comes to simplification or transposition involving roots and powers would have obviously been the fact that this information may have been missing from your skill archive. So now that we have this information, then let us proceed into looking at some examples. And these examples that I've come up with here are structured and progressive examples that are going to bring out a lot. It's going to bring out a lot of what you learned in part 1 of my video, and it's going to bring out a lot of what you learned in part 2 of my video. So if you're at this stage here in this video, right, you definitely would want to have the prerequisite knowledge for you to understand completely what's going on here. Now I've made the questions simple, but I will allow them to progressively get a little bit more challenging as we go along. So here we go. Let's get right into it. So starting off here with this exam structure type question here, where we have V is equal to the square root of T over M, and so we are required to make M the subject of the formula. So to make M the subject of the formula, obviously we need to be able to have access to M. But the immediate problem here that we have is that M is covered by a root sign, which in this case is, say here, the square root. So the very first step in solving this question here is to pretty much isolate the M away from the root. Now to do that, we obviously have to balance the equation by whatever we do on the one side, we're going to do it to the other side. So what's going to happen here is that for me to remove that root symbol here, let's just rewrite it as the square root of, say here, T over, say here, M. What I'm going to do here is that I'm going to have to square root, I'm going to have to square the left side of the equation. And so to balance that, we also have to square, say here, the right side of the equation then. So by doing that, then we end up with, say here, V squared becomes, say here, V to the power of 2. And so therefore then what's going to happen now is that the square will cancel the square root, which is exactly what we had looked at up here in this section here. So you can see right away that our knowledge that we just garnered in that part there is now being applied almost immediately. So then what we now have is V squared is T is equal to T divided by M. Now we're not going to waste any time trying to use any cheeky methods. We're just going to apply all of what we've learned before. Obviously, that the required subject is in the denominator. So we have several things we can do here. We can multiply both sides, say here, by M and cancel the M on the right and get it to be on the left, and then split the product. But remember, we showed you the shortcut in part 1 where if the subject is in the bottom of the equation, we can do like a little swap. So we can swap here and here. So we're just going to get to the business end here. Put the M where the V square was, and then obviously we're going to put the V square where the M was, and then voila, that is your answer. All right, so the only time you can do that little swap is when your denominator is in the LCM and the equation is a 1-to-1 ratio. That's the only time. It has to be a 1-to-1 ratio, meaning that we have to have one term on the left being equated to one term on the right. If it's not a 1-to-1 ratio, then the swap cannot be done, and then you have to eventually multiply each term in the equation by the denominator. All right, so beautiful. We've just looked at an example that involves square root of a fraction. Let's look at an example where we have, say, another root symbol here that involves a product. So here we have x is equal to the cube root of 2gr. So what this means then is that I'm going to have to cube both sides of the equation, because in order for me to remove the cube root, I have to cube the equation. So I'm going to go ahead and I'm going to say x that's raised to the power of, say here, 3, and that's going to be equal to, say here, the cube root of, say here, 2gr, also raised to the power of, say here, 3. Okay, I'm so accustomed to writing the square root, guys, but this time it is 3. So what this means then is that the cube root here will be cancelled by, say here, the 3, and we already discussed how that is possible, because the cube root of 2gr is really 2gr raised to the power of a third. And so therefore, by multiplying this now by the reciprocal power, this cancels this, so therefore we end up with 2gr. So we've already discussed this in the earlier part of this video, so hopefully you guys understand why we cancel the cube root with the cube. Okay, so therefore then, once that is done, we end up having x cubed here, and that's going to be equal to then what is under the root, so that's 2gr. Keeping our eyes on the target here. The target here is to get r to be by itself, so obviously then easily, in order for us to isolate r, we would have to divide both sides of the equation by 2g, so we end up with x cubed. Okay, let's just make this the correct x here. So we're gonna have x cubed, and we're gonna divide this side of the equation by 2g, because we do not want 2g to be on the right side of the equation. So that's 2gr divided by 2g, and so easily then the 2 cancels the 2, the g cancels the g. Therefore our final result is that x cubed divided by 2g is going to give us the result of r, which is our intended subject. All right, so nicely done there, nicely done. All right, lots of stuff are coming out here, guys. All of what we've learned in part 1 is actually presenting itself here. All right, let's just put a little box around this as well. That's the answer for this section here. And what I do recommend though, guys, is that you actually attempt these questions, and so therefore you can match your solutions with, say here, mine. All right, so we have another question here, and that is in fact, say here, the pendulum equation or the pendulum formula. So a tricky little example here that we're going to be going through. Now we have here t is equal to 2 pi square root L over G. Let us first understand what this 2 pi square root L over G means. It literally means, and let me just use a different color here. It literally means that, say here, 2 pi is actually multiplying, say here, the square root of L over G. So that's what it literally means, all right? And so therefore then, as usual, we are looking to make L the subject, and once again you can see that L is under the root. So to do this then, we're going to have to say square both sides of the equation. So we're going to go ahead then and we're going to write down t raised to the power of, say here, 2, all right, and say therefore then this is going to be 2 pi, okay, square root L over G, and we're going to obviously square that side as well. And so by doing that then, what I find over the years that I've been teaching is that many students tend to go ahead and they in fact cancel the square with the square root, but what they forget to do is that this is a product, so the square affects everything in the product. It's just that, notice that the product of 2 pi square root L over G, the square root basically only covers the L over G. So by squaring, the square does not affect the L, nor does it affect the G because it was covered by the square root, but it actually affects the 2 and affects the pi. So what you find is that if you are actually attempting this question, you might find yourself making the error right here, where t squared is therefore equal to 4 pi squared L all over G. And that's where the error is. Most students forget to square the 2 and forget to square the pi. And then the L now, obviously, even though the G is just under the L in the question, it means that it's a denominator for the whole entire product or the whole entire fraction then. All right, so that's where, if you've made an error, that's where the error would have been made. All right, now bear in mind here that we need to say here, get L to be the subject. So in this case here, our L is in our numerator, and according to the rules in part 1 that we had discussed, that if the numerator, if the subject is in the numerator, then it requires us to cross multiply. So therefore then we're going to be starting off, say here with this side, let's put the t squared over 1, and so obviously 1 multiplied by this numerator up here will give us the actual numerator, 4 pi squared L, and so therefore that's going to be equal to, say here, t multiplied by g. All right, t multiplied by g, that is going to be tg. All right, beautiful. And so therefore then, remember that we're trying to find the L as the subject, so we therefore need to get rid of 4 pi squared. So splitting the product, then we're going to simply end up then with, say, 4 pi squared L divided by 4 pi squared, and that's going to be equal to, say here, tg divided by 4 pi squared. Okay, and then now simply we're going to be doing a cancellation. So the 4 cancels the 4, the pi square cancels the pi square, and then we're left easily then with L being equal to whatever is on the right, tg, all divided by 4 pi square. And this here is our final result. L is equal to tg divided by 4 pi square. All right, beautiful, nice question then. All right, let me know in the comments if you were able to get to a section. Let me know what part of the question had you puzzled, and let me know in the comments. All right, let's move on to some more challenging questions then involving the square root. Now, you just learned just a few minutes ago that once you have a term outside of the square root, if you happen to having to get rid of the root sign, then it will affect the term on the outside, but it will not affect the term on the inside. So here we have f is equal to 1 divided by 2 pi square root t over m. Let us just change this m to the correct m that I'm having here. Remember, we discussed this in part 2, where we have to pay attention to the letter that is being used here. So make m the subject. So once again, we're going to start off easily then with the fact that we have to square both sides of the equation. So we end up then with, say here, f, we end up here with, say here, f squared, pardon me, let's write that better. So we end up here with f squared is equal to, say here, 1 over 2 pi square root, say here, t over m, and we're going to square this side as well. All right, balance the equation. So therefore we end up with f squared. Bear in mind that the square will affect the 1, so that remains as just 1. If it was 2, it would be 4. If it was 3, it would be 9. So square the 1, we get 1. And remember now that we're going to square the 2, we're going to get 4. And when we square the pi, we're going to get pi squared. So that's 1 over pi squared. 1 over 4 pi squared. And then of course the square also affects here, cancels the square root. So we're also left with t at the top. So we can just erase this here. All right, so we're gonna end up with 1t, all right, at the top. So 1 times t is really t. We don't need to write the 1 anymore. We'd only write the 1 if it's a case where only the 1 was available. So that's 4 pi squared, and then of course the m is at the bottom, so that goes here. So we end up with f squared is equal to t divided by 4 pi squared m. Now we have to get m to be the subject. Here you recognize that our subject, our required subject, is again in the denominator, so we can do that little swap. Okay, so we can just transfer this information here. Okay, and so we can put 4 pi squared m in the position of the f squared, and then therefore put the f squared in the position of the 4 pi squared m. So that's going to be f squared. All right, and then easily then now we need to isolate, say here, m as our subject. All right, we need to isolate m here as our subject. So we're going to therefore divide both sides by 4 pi squared. So therefore then we end up say here with 4 pi squared m divided by what we want to get rid of, which is 4 pi square, and that's going to be equal to, let's just write this a bit smaller, t over f squared. So that's t over f squared here, and then down here we're going to have t divided by f squared, and we're going to obviously multiply by the reciprocal. Okay, so remember that when we're dividing by a term, we're going to multiply by the reciprocal, so that's going to be at the top here 4 pi squared. Remember, when you're multiplying by, when you're dividing a fraction, you're going to change the sign to multiplication and reciprocate. So the 4 pi squared, which was at the bottom, will therefore end up at the top. So therefore cancel now, we end up cancelling then. So 4 cancels 4, pi squared cancels pi squared, so we're then left with m is equal to, say here, t times 4 pi squared. So that's going to be 4t pi squared. All right, we conventionally like to write the numbers before, all divided by f squared. All right, tricky little question, dear guys. If you meet this in an exam, you're going to definitely need a lot of practice prowess to get through this question. So it's a tricky one, and that's the purpose of the video. The purpose of my videos are to give you as much experience as possible when it comes to resolving these types of transposition. These are transpositions that you don't find a lot of instructors talk about, but they are very, very useful. The skills that we have garnered here are very useful later on. All right, and then now we're going to be looking at the fact that v is equal to k square root fl over m. Now we're dealing with the case where, again, it's kind of the same, right? The last two examples dealt with a term outside, so it's the same procedure here. Let's just proceed. We're gonna have v squared, okay, on this left side here, and remember, it's not always a square. Even though my examples are square roots, if it's a cube root, you would cube both sides. If it's a fourth root, you would raise the power of 4 to both sides. So just trying to keep it simple here, guys. So this is going to become k squared, and then of course, obviously the square will cancel the square root. So let's just do here, square this v here, and then square everything here. So then the square attach itself to the k, so that's k squared, and then the square cancels the square root. So we end up with, see here, f, all right, l, and then everything then automatically goes over m. And so remember, l is the subject, so we're going to cross multiply. Okay, so we're going to cross multiply by putting this over 1, so this comes up here and that goes down there. Start off with this side, 1 multiplied by the numerator gives us obviously the numerator, so that's k squared fl, and then obviously then v squared multiplied by m gives us mv squared. And then now to isolate l as a subject, we need to divide both sides by k squared f. So therefore then k squared f l divided by k squared f l is therefore equal to mv squared divided by k squared f l. And so easily then we can cancel. Okay, so the k square cancels the k square, the f cancels the f. So finally then L is equal to mv squared divided by k squared. Okay, so k squared f L. Alright, and that there becomes our final result. So the first 4 or 5 or 6 examples that I've done, I've shown you how the terms cancel. Okay, we've done all of that wonderful stuff. Now in this next section there, I'm going to be skipping out a few steps, right? Because we now understand how a term in front or underneath is eliminated. Now we're going to be just doing the opposite here, right? Because of course we can't leave the video without going through a bunch of examples, say here, involving multi-step. So I'm going to just add an extra layer here. And this extra layer here is that we're going to be removing the power at the end. At the end of the equation, we're going to be removing the power. Now, these are advanced questions, all right? And I do have a really interesting one here that's going to take us to the end of the video. This is probably the question that I saw when I was learning maths for the first, like when I was learning this topic. I found this question super challenging. So I thought that I would just add this to your lesson today. All right, let's see if we can wrap these questions up in the next 20 minutes. Let's get right into it, guys. Now we have k is equal to the square root of 1 minus 2p squared all over n. So therefore, how do we approach this question then? Let us start off obviously by removing the square root, because the intended subject here is p. P is what we want, but there are so many different variables that are connected to p. First, we have to get rid of the square root. Then we obviously have to get rid of the n next. Then we're going to get rid of the 1. Then we're going to get rid of the coefficient of 2. Then we have to get rid of the square. So this is going to take about a good 5 steps. I'm going to skipping out some stuff that we already went through. We know exactly what's going to happen. So I'm going to try to be as efficient as possible here. So obviously then I'm going to have to square both sides of the equation here. And so what that does for me then is that it gives me the value that k squared is therefore then equal to, say here, whatever is under the root. So that's 1 take away 2p squared all divided by, say here, n. Remember that the square root will be cancelled by the square or by the power. All right, so we left with what is under the root. Now we're going to have to cross multiply here. Okay, so we're going to start off obviously by putting the k squared over 1, and we're going to cross multiply this way, and we're going to go that way. I always like to start in the direction that leads me to my subject. So therefore then I have 1 multiplied by whatever is here. I'm going to end up with, say here, 1 minus, say here, I'm going to end up with 1 minus 2p squared on my left. And then therefore I'm going to end up then with k squared times n. I could write k squared n or nk squared, doesn't matter. Nk squared. Okay, nicely done there. Then obviously now I need to try to get rid of the 1 here. Now the thing is, I really do not like leaving my subject negative. We had an elaborate discussion in my equation solving fractional equations video where we spoke highly of why we should not leave our subject negative. So in this case here, I'm going to therefore start by, as opposed to transposing the 1 and leaving my subject negative, I'm going to therefore just transpose the nk squared to the left and then transpose the negative 2p squared to the right. So I'm going to end up with, say here, 1, and this here is positive, so it becomes negative, so that's 1 nk squared. And then obviously when I carry the negative 2p squared to the right, I'm going to end up with positive 2p squared. All right, let's just transfer this information up here, and then therefore then we know I could just turn this equation around, right? I could just turn it around. I could therefore just write 2p squared now on the left, and then equate that to, say here, 1 minus nk squared. All right, so it's the same thing, guys. I've just turned the equation, say here, around. Now I need to isolate the 2 away from the p squared, so I'm going to divide both sides by 2. So already we know that once we divide the left side here by 2, the 2 is going to cancel, so I'm going to be left with p squared, and then therefore I'm going to have 1 minus nk squared all divided by, whoops, here we go, it's all divided by, so it's nk squared, and then all will be divided by, say here, 2. And then now here is where we had discussed this earlier. Let's just go back to that slide that we had, the slide where we spoke about how to remove, say here, the power. So here, if we had, say for example, I think we had it here, was it this? Okay, it was down here that we had, say, a square attached to the variable. So to remove the power, we're going to use the corresponding root. So by using the corresponding root here, what we're then looking at is in fact square rooting, say here, p squared. And of course, if you square root the left, right, or the left side of the equation, then we obviously have to square root the right side as well. So we end up with the square root of 1 minus nk squared all divided by 2. And so obviously the square root will cancel the power. So then we leave with a final result here of p being equal to exactly that, square root of 1 minus nk squared all over 2. All right, that is how you would transpose an equation. Now what I usually do when I was practicing my math, once it is that I've gotten my answer, what I will do is then I will just retranspose the answer that I got and try to get back the question that was given to me. So I would then go ahead then and try to reverse my steps. I would go ahead then and use this as a question, and then I would transpose and make k the subject. If I transpose and make k the subject, I should end up back with the question that was given to me here, and then you can then confirm that you are definitely a master at transposition. All right, let's then move on to a similar question. Nothing different here. Well, something subtle different is that we're looking at the cube being attached to the intended subject. So I just don't want you guys to think that it's always going to be a square root. It can literally be any power. For Csec, for SEA, I'm not certain that these type of question comes in the SLC syllabus or the SEA syllabus. I know for certain that I've seen 1 and 2 of these questions in Csec, but as I said, my video hits a broad spectrum, so college students can benefit and secondary education students can also benefit then. So let us start off here with, obviously we're gonna have to square both sides to remove the square root, because our subject here is under the root, so it's covered by a square root. So we're going to square the left side, which is obviously going to be, say here, p squared. Okay, remember that we square the left, and we also say here square the right. Okay, so p squared is equal to whatever is under the root, so that's going to be 5m cube plus 3 divided by, say here, r. Bear in mind that the p squared is a numerator. All right, beautiful. Let's just make this a little bit better here. Now again, our subject is in the numerator, so that means already that I have to cross multiply. So I'm going to start off by putting my p squared here over 1. I'm going to cross multiply here and then cross multiply down there. So starting off with the side that leads me to my subject, 1 multiplied by the numerator gives us exactly the numerator, 5m cube plus 3, and therefore that's going to be equal to p squared times r. That gives rp squared or p squared r. Doesn't matter, guys, whatever you prefer. Okay, and then now easily then, unlike the example up here where I carried the subject to my right and carried my subject to my right because it was negative, here my subject is positive. So now I'm going to just use the usual transpose, say here the 3 to say here this side. Okay, I don't have to worry about my subject being negative, so I just carry over the constant. So that's going to be 5m cubed, and that's going to be equal to rp squared, take away 3. All right, and so therefore then we're going to divide both sides then by 5. So you know that if we divide the left side by 5, the 5 is going to cancel, so we're going to be left with m cubed, and then obviously when we divide over here by 5, we're going to end up with rp squared minus 3 divided by 5. And so perfect example here, we're now a power of 3 is attached to our subject. We can't use the square root to cancel the cube. We have to literally use a cube root sign. All right, so we're going to have to cube, say here the m cube, and then of course we're going to cube root again the right side of the equation here. So we end up then with the cube root of rp squared minus 3 all over 5. And so the cube root will cancel the cube, the power of 3. So we end up with m is equal to, say here, the cube root of rp squared minus 3 all over 5. And that is our final result. All right, fantastic. Tricky question, is it? Let me know in the comments down below. What do you think? Have you ever seen a question like this before? Have you ever had to challenge with this question before? Let me know. Put a timestamp. Let me know where you may have made the error. If you did, and if you have gotten it perfectly correct, then give this video a thumbs up. All right, so we're coming almost to the end of the video, but I definitely want to make certain that I kind of attack more exam structured type questions. So here we're looking at a question that I saw in a textbook. It came from the Csec General Proficiency Exam in 1983, where we were given this equation to make n the subject. All right, so we're going to be walking you through this. All right, so it's going to involve a little bit of what we had discussed in part 2, where we're going to be factorizing. So as we're approaching the end of the video now, we're looking at, say here, attacking everything. All that we have learned so far in this video, as well as in part 1 of the video and part 2, will play an important role. Let's get right into it. M then is equal to the square root of 1 minus n squared over n. We are to make n the subject. So of course, naturally then, we're going to go ahead and square both sides of the equation. So we're going to square m here, and we're going to square this side here. So what that means for us then is that m squared is equal to the square root will be cancelled by the square. So we end up with 1 minus n squared all over n. In part 2, we discussed that if you're transposing an equation with more than one of the required subject, we know at some point you are going to have to factorize out this expression here. Now, before we get into that, both the subject is in the numerator and in the denominator. So in this case here, I'm still going to have to cross multiply, but it doesn't matter which side I start with. I particularly will start with this side here. Okay, I want to always keep my subject positive. So m squared times n will give me n m squared, or m squared n, doesn't matter. Okay, and then of course 1 multiplied by whatever is at the top will give you exactly what is at the top. All right, and then remember that of course we're trying to make n the subject. There's an n on the left and there's an n on the right, so the obvious thing to do here is to transpose the n's on the same side, whether on the left or on the right. So I'm going to carry this negative n squared to this side here. So I'm going to end up with nm squared, okay, nm squared minus, well, in fact, minus comes over, becomes a plus. So that's plus n squared, and that's going to be equal to, say here, 1. And so just like in part 2, we have to factorize out our expression here. So we're going to be factorizing, say here, we're going to be factorizing here, say, n. All right, pardon me, I think I made a mistake. Let's see here. Hold on, give me a second, guys. I think there's a problem with this question. There is in fact a problem. Ooh, I think there's a little trick here, because I think I did this question earlier, but I think I made an error in my rough work, because now the common factor on the left here is n, and if I factor out the n, I'm going to be left with m squared, and then of course n into n squared goes n times. So that's going to be a problem, because obviously we cannot solve for a subject. We cannot solve or transpose for a subject and the subject is still in the answer. So this could either be a mistake in the question that came from the textbook, or maybe we need to be a little bit cheeky here. Let's try something. Let's discover. Okay, because this is definitely a problem. I did not see this one coming. So at this point here, we can't really go any further because we have the n outside. But if we divide both sides by m squared plus n, the n is still in our answer. So let's rewrite this line here up here. Let us see what we can do. So that's nm squared plus n equal 1. Alright, so after pausing the video, I think that there may have been an error in the question. Literally, guys, what we're trying to, let me just erase what I had done here. What's the problem here in this question is that if you're trying to make something the subject of the equation, then if we divide, say here, both sides by m squared plus n, then n then is equal to 1, right? We divide both sides by m squared plus n. On the left side, it cancels. Divide on the right side here, we end up with 1 over m squared plus n. And the problem is, if we have n as the subject, n can't be in our answer. So there is a problem then that we have here. So it could be an error in the question. This is definitely not the answer. So there is definitely an error here in the question. I'm not sure if maybe the question, because I'm looking at the textbook now and that's exactly what I'm seeing. So I'm not so certain. It doesn't matter what we do here. It doesn't matter what we do. We're gonna get the same thing here. Okay, guys, so I don't see a way around this question. I'm obviously gonna have to leave it here, but let me know in the comments, right, if you guys see a way around this. I don't see a way around this, but I'd love to hear from you guys in the comments. All right, but we're gonna have to move on then and bring this video to the end. So perhaps if I get a solution to it, I will leave it in the comments with a timestamp. All right, but let's move on to this yet another challenging question. And here we have a is equal to pi, open bracket, r minus big R minus small r, all divided by 2 squared. There's a lot of stuff happening here it just looks very simple, but there's a lot of stuff happening here, and you'll see what the solution looks like at the end. So I'm going to try to be as efficient as possible here. Now, of course, we need to make, I think the question, I think it was, let me just confirm here, guys, what the subject was. It was, in fact, to make this big R here the subject of the formula. So we needed to make that the subject of the formula. All right, so let's get into it without further ado. So very first thing here is to get rid of that power here. And again, there's a couple of ways. I'm gonna be doing both ways for you. Let me know which method you prefer. So here we have a is equal to pi open bracket big R minus small r all divided by 2 all squared. So step one here, I'm always instinctively wanting to get rid of that power. So I'm gonna square root, say here the a, and I'm gonna also say here square root everything that is on the right side here. So that's going to be pi open bracket big R minus small r over 2 squared. So what this means for me then is that the square root cancels the square, but remember that the square root also affects the pi that is on the outside, because the pi is literally not attached to the power here. So that's the trick with this question here. All right, many students, that is what may have slipped you. So therefore you end up with the square root of a is therefore equal to the square root of pi open bracket r minus small r over 2. Now if you're not able to get to that section, whatever it is that you've done is going to be incorrect, because that square root of pi here is the key. Now let's just transfer this information here on the other side. So by transferring this information on the other side here, we have this equation here, and so now we have to distribute here. All right, we have to distribute. So I'm going to go ahead, then I'm going to distribute the square root of pi. So I'm going to distribute the square root of pi here and distribute the square root of pi here. So therefore then we end up with the square root of a is equal to the square root of pi times r is r square root pi, and then of course that's going to be minus the square root of pi times small r is small r square root of pi. And then obviously then we know that everything is now going to be over 2. All right, remember that the subject here is the big R. This is the focus. The question mark is on that R. So therefore we have to cross multiply. So I'm going to start off by putting this over 1, and I'm going to cross multiply here and then here. So a lot of what we've been doing is still being done in this question. It's just that the question looks a little bit more complicated in terms of its appearance. So then we're going to start off with the subject side. So that's 1 multiplied by the numerator at the top gives us exactly what is at the top. R, big R, square root pi minus small r square root pi is equal to 2 multiplied by the square root of a. So that's 2 square root a. Then obviously we need to isolate r square root pi. So we're going to transpose small r square root pi to the right side. So we end up with big R square root pi is equal to 2 square root a plus, because we transpose this to the right side, small r square root pi. And then obviously then to isolate r, we need to divide both sides by the square root of pi. So when we divide the left side here by the square root of pi, the square root of pi at the top will be cancelled by the division of the square root of pi at the bottom. So we're then left with r. And then obviously on the right side, we're going to end up with 2 square root a plus r square root pi divided by the square root of pi. All right? Or as some teachers will write, 2 a to the power of a half plus r raised to the pi to the power of a half, all divided by pi raised to the half. Some teachers will write the answer like that. All right, and that is how you'd approach that question. So if you've ever seen that question, if you've ever been challenged, then you've just gotten your solution. Now, of course, just to end the video here, I'm going to give you an alternative approach. So then we have, say here, a is equal to let's go back to the question. A is equal to, okay, a is equal to pi. Okay, so a is equal to pi, open bracket, big R minus small r over 2 all squared. I could start off by dividing both sides by pi. So I could split the product between the pi and the binomial fractional expression here raised to the power of 2. So I could go ahead and say pi. I could divide both sides by pi by saying a divided by pi is equal to pi, open bracket, big R minus small r over 2 squared, all divided by pi. So then what that allows me to do then is to split the product between the pi here. So we end up with a over pi is therefore equal to big R minus small r over 2. Don't forget the square, all squared. I would therefore then go ahead now and eliminate the square. So I could therefore then go ahead and square root both sides. So I would square root, say here, a over pi. And then obviously, if I square root the right side, basically then, if I go ahead and do this, cancel, cancel, I'm going to be left with big R minus small r over 2. So then we'll go up here and then we're going to cross multiply. So we're going to start off with, say here, square root of, okay, so the square root of a over pi is basically the same thing as the square root of a divided by the square root of pi. And that's going to be equal then to big R minus small r all over 2. This allows me then to clearly know what I'm going to multiply the 2 by. So then I can say 2 times square root of a becomes 2 square root a. And then of course the square root of pi will multiply the big R and the small r. So the square root of pi times r is r square root pi. And the square root of pi times small r is basically small r times the square root of pi. This is just an alternative approach, guys. Maybe a little bit harder, but I don't know. It just depends on you, really. And so therefore then I can bring over this negative r, this negative small r squared pi to the left side. So 2 square root a plus r small r squared pi, and that's equal to big R square root pi. So naturally then, to get r, I'm going to divide both sides by the square root of pi. So that's 2 square root a plus small r square root pi, all divided by square root pi, will give us the value of r, which you can see is the same answer that we got up here. 2 square root a, 2 square root a plus r square root pi plus r square root pi divided by the square root of pi divided by the square root of pi. So 2 different approaches to the same question. Let me know in the comments what method you prefer. All right, tough question, tough question. but I personally believe that if it is that you can actually challenging questions like these at the Csec level, you can completely master the topic of transposition. All right, and this brings us to the end of our transposition series of videos. Use the tools that I've given you in part 1, in part 2, and part 3. Transfer that knowledge then into topics coming up, because of course, as I said, transposition is probably one of the most important topic in math. Now that we have finally covered in its entirety the topic of transposition, I then wish you all the best going forward with your transposition problems. And of course, feel free to hit me in the comments. Let me know if you have any particular question that you'd like me to do for you. And then from there, we can continue improving. Alright, so to all my Csec students, all the best in your upcoming exams. And to all students that are at the college level, of course, as well, all the best in your exams coming up as well. I hope this video was of some value to you. With that said, please do not forget to subscribe to the channel, turn on your post notification bell, and hit the like button before you go. Until then, take care, and I'll see you in the next video. Bye bye.